So go to the little start box, type in NetBeans. N-E-T-B, that'd be enough. NetBeans. And click that. And this is going to be real slow to come up if it's the first time we've run it on these machines, so just be a little bit patient. And if you're playing along with this at home, just watch. You don't have to install NetBeans just for 5 minutes worth of assignment. Guess I really can't shrink the resolution of the display much more. Now go to File. So everybody got it loaded. I don't want to go too fast because if I go too fast then we good? Alrighty. File, New Project. File, New Project. Java Application. Then click Next, click Finish. Who cares what we name the project? Now I need to change the font size. You don't have to do this. All right, hopefully that'll work. All this stuff in gray are what's known as comments. I mean, you know the comments, but they're done in a different style than what we've seen in Python, but it's the same idea. Okay. The last comment I just deleted was one that says to do code application logic here. That's where we're going to be making our changes. So you could delete that comment or whatever, but between the two braces, between that one and that one, we need to do a couple of things. The first thing we need to do is to declare a scanner. What a scanner is it allows us to get input from the keyboard. This is more trouble than it is in Python. Okay, so you type the word scanner, but you type it with a capital S, unlike Python where almost everything is a lowercase s. And then just do an S after that. Scanner S equals new scanner. This is a bunch of typing. And then some parentheses. And inside the parentheses, type system.in with a capital S and put a semicolon there. And you know what? Even if this program doesn't work, it's going to prove the point that I want to show y'all. Now, after you do that, you're going to get this little red error on the side. That's going to say, I don't know what a scanner is. So up here at the top, we need to add an import statement. However, and I hate to show y'all this. As a matter of fact, I'm not going to show y'all this. Okay, so go up to that line that says package, and underneath it, do import, I-M-P-O-R-T, Java dot util dot scanner semicolon. Every line we type, or well, at least a lot of the lines, I think every line that we're going to type is going to end in a semicolon. All right, now we're ready to do some stuff. We're going to print a message out. We're going to get some input. We're going to do some conversion, and we're going to print something else out. All right. What kind of conversion are we going to do? Let's do, I don't know, Fahrenheit to Celsius. It's the easiest one that comes up to my brain. So, system with a capital S dot OUT, all lowercase, dot PRINT, parentheses, And it filled in some parentheses, and it put the semicolon there, and I put that S there. Delete that S, and instead put enter temperature in C. Something like that. Next, we need a variable to hold that temperature. So double C, double space C, all lowercase, is equal to S dot next double, parentheses in parentheses, like that. Now let's do the conversion. Double F is equal to C times 1.8 plus 32. One more print statement and we're done. System.out.print line the temp in F is, I need to drag this over to use up all my space, don't I? Plus an F, like that. All right. You may have syntax errors or whatever. That's okay. When I run it, there's going to be a little output window down here, hopefully. It says enter the temperature in C. I'm going to type in 100 because I know that's 212 in Fahrenheit. Okay. That's a legit program. It works. So, if you turn in pseudocode that looks like this, print enter temp, don't type this stuff. Let me drag this over. I know that y'all are actually going to probably all want it to work. Enter temperature in C. C is equal to input. C is equal to float C. F is equal to C times 1.8 plus 32. Print temperature in F is, comma, F. You see there's a fair amount of difference between the two, right? And trust me, there's at least that much difference between the way this would look in C++. So the point is if you're writing pseudocode, you don't want to put a lot of program-specific stuff. You don't want to put a lot of logic. If I wrote this and I handed it to you, and I called this pseudocode, and I wanted you to go implement it in Python or PHP or something, and you went over here, you'd get upset at me that I threw in all this syntax that you didn't need to know. For example, at the very least, this one doesn't even have a float command. It didn't need to do any conversion. The input handled that. Or if I took advantage of the fact that Python does input and output on the same statement, we could do this. Enter temperature in C right there in the same statement. That looks even worse to a Java programmer. They have to break this up into 2 lines. Ignore this one. It's just totally different. So if you make your pseudocode look too much like Python, you probably think you're saving yourself some time because you're going to implement it in Python later, right? You may be handing this off to somebody else to implement in another language. Write pseudocode in a very generic, simple form. Don't make it look like Python. If you made it look too much like Python, you may have gotten a 1 or a 25 or something like that, even if it was an awesome program. You wrote one that looped and stuff like that. It's awesome. You turn that one into the Python box, and you're going to get extra credit for it. But this one, no. So I hope that you can see that syntax, the concepts are very similar. Printing stuff, getting input. The word input doesn't appear anywhere in this thing, but we are still getting input. Doing some calculations, doing some output. It all looks very similar, but the specifics are all very different. All right, I hope that proved the point. So pseudocode. There's an example of it in the last page. And oh, by the way, check your assignments, your instructions as you're doing it. because a lot of people only did half the assignment. They did the temperature C to temperature F, or they did the kilograms to pounds, but not the other one. So you only got half credit, but just revise it and upload it. Then you'll get full credit. So pseudocode starts with a start. All you need are output words, input words, set, and eventually we'll have ifs and whiles. That's pretty much all your pseudocode needs to do. I'm not going to ask you to pseudocode much that's more complicated than that kind of stuff. Does that mean that our programs are all going to be that simple? Nah, we're going to do some fun stuff. And as a matter of fact, that's what we're going to do today. We're going to play with turtles. I have an aquarium full. No, we're going to play with on-screen turtles. Let's go to how to think like a computer scientist. We don't really need to because I can just show you this by hand, but I want to show you where you can read more about them. So over here in the textbook, how to think like a computer scientist, we want chapter 3 called Hello Little Turtles. And here's some code, but we're going to type our code in and we're going to make it different than theirs. So go ahead and launch idle. You can close NetBeans if you want. Do a file new. Don't name your program Turtle, even though that's what we're working with. That'll mess you up in the future. Let's name it after one of the Ninja Turtles. Let's call him Leo for Leonardo. Okay, so file, save as, Leo. Don't save it in the guts of the Python directory. Put it in the desktop or wherever your favorite folder is. Put your name, date. Alrighty. Now the top thing we need to do, just like in our Java program, I had that import scanner. What import scanner did is it brought in a library, a class of functions. Well, we're going to bring in a library of functions too called the Turtle. Import Turtle, all lowercase. Now we need to make a turtle. Let's do the next thing. Well, yeah. What are we going to call him? Leo. Leo's equal to turtle dot turtle with a capital T, parentheses in parentheses. I apologize for the weird syntax, but I didn't make it up that it has to be a capital T there and a lower t there. Alrighty, the next line. Win, short for Windows, is equal to turtle dot, you don't have to put the spaces, screen, parentheses in parentheses with a capital S. Now we're going to make Leo do some stuff. Leo dot forward, and people always have challenge typing forward. It's not that you don't know how to spell it, it's just that everybody's finger skips the R, the first R in forward. We're going to make him go forward 100 pixels. Then we're going to make him make a left turn and go forward again. So Leo.left, and a 90-degree turn is a right angle. So Leo.left, 90 degrees, and then go forward another 100. Then go make another left turn. And then we're going to add one last command. Put it way down at the bottom, and everything else we type is going to appear before this command. Windows dot or win dot main loop. And I'll show you what that's for in a minute. I'll show you what it's for right now. Uno momento. You may have tried this. If you go and you double click on a Python script and it asks for some information, Well, that one's a bad example. Inner distance in feet, inner distance in meters, and it closes it before you can see the result, right? Well, there's a way you could fix that. You could just put a dummy input statement at the bottom. But this is going to be effectively the same as our dummy input statement. It's going to keep Python up and running, even if we ran it from the command prompt or ran it from a folder. Okay, let's run it. Run module, save it, and we can see what our turtle did. He drew 2 lines. Let's slow them down so that we can watch them. So above, or maybe, yeah, right below the place where we create the turtle, let's set his speed. Leo.speed, we're going to set it to 1. 1 is the slowest he can go. Later on, when we get bored of watching him, we're going to set it to 0, which is the fastest he can go. That sounds silly, but 1 is the amount of delay, and if you make it 2, 3, 4, 5, 6, 7, 8, 9, 10, it puts less and less delay, but you can skip the delay altogether by making it 0. Okay, so we can see what he's doing. We can change his color. Maybe above the first forward statement, let's make him green. Leo.color, parentheses, and the word green has to be in quotes. It's a string. There we go. Now we have a green turtle. Just a sec, I'll walk around and make sure everybody's okay. I bet you can already see how to make it draw a square, right? We've already drawn half the square. Modify your program once you've done that to make them draw a complete square. Looking up something to make sure I don't make a mistake before I do it. Alrighty. Let's make him look different. Right now he's, what kind of cursor does he look like? I think he's a little triangle, a little Star Trek emblem. Under Leo.speed, or above it, type Leo.shape, and then inside the parentheses, put some quotes and put turtle. We're just going to change his shape to a turtle. All right, that's cute. So when this was first invented, the turtle was actually a mechanical device. And you'd roll out a huge piece of paper, you'd put the mechanical turtle on it, you'd program it in, the turtle had a pen, it would draw shapes. It was how you taught kids, or conceptually it was how you taught kids to program. You were drawing shapes on physical paper with a mechanical turtle. Obviously, you don't need physical paper and a pen in order to get this to work. But the fact that it's a pen kind of implies that you can lift the pen, you can put it back down, you can lift the pen, you can put it back down. I don't see a need for us to do that, but we can do 2 cool things that the physical turtle can't do. Like, a paint bucket and a paint program that fills a shape. We could paint our square. If you don't have the square, all you need to do is copy those 4 lines of code that we already did and paste them. Those will draw the other 2 sides. All right, I'm going to type 1 more command, 2 more commands. We're going to fill the square in. And then I'm going to wander around and make sure everybody's got it done. If you do have it done, I want you to make him draw a second shape, a red triangle. Okay, so underneath Leo.color, do Leo.begin_fill. We do have to have the parentheses, but there's nothing inside it. So we just added that. Don't add these comments. I'm just pointing out what we changed. I mean, you could. All right, and then down here at the bottom, right before the very last thing we do, above that main loop, do Leo.end_fill, parentheses. So not only does he draw the square, we fill it in. Last thing I'm going to show you before I go further is the color command can accept 2 parameters as well as just 1. If I do this green, I'm going to modify my color command. I put a comma after the word green, and I tacked on blue as a second argument, comma blue. Now when he runs, when he fills it, it's going to fill it in with a different color he's drawing it. That's not really what I wanted. I'm going to undo that change. All right. Okay. So right here, underneath that end fill, is where I want you to draw a triangle, if you have it all working already. I'm going to wander around for those of y'all who don't. It's like a packed room on this side. Good on this line, or okay. When you get tired of watching him go so slow, change it to speed of 0. He'll go lightning fast. You got it? Okay. Four copies because he's drawing 4 sides. 1, 2, 3. One more time. Yeah. I'll give y'all a hint to draw a triangle. Actually, geometry time. The sum of angles in a polygon and a regular polygon have to be 360. So that's 90, that's 90, that's 90, that's 90. If you want to draw a triangle, it's 120, 360 divided by 3. This pen's not much better than yellow. If you wanted to draw a 6-sided figure, hexagon, like I can do that, then it's 360 divided by 6, which is 60. Both of these are kaput. So for the second half of this, I want to draw a red triangle. I'm going to push that stuff up. I hope everybody had it working. I'm going to set its color to red. Leo.color red. I want to start filling. Leo.begin_fill. Then I'm going to draw 3 lines with 120-degree angles. Leo.forward 100. Leo. I'm going to make my turn right rather than left. Right 120 degrees. And I'm just going to copy and paste those 2 lines because he has to draw 3 sides. And after he draws 3 lines, let's do Leo.end_fill. Alright, why do we play with the turtle? Besides the fact that it's fun to draw things on the screen, like grabbing crayons. It illustrates actually a lot of concepts of computer science, one of which is the idea of an object. Leo is an object. What is an object? An object is something that has more than one piece of data. You know, right now we've done C is equal to 100 or whatever. C is a variable that holds one number. Leo's got a lot of information, doesn't he? He's got a color, he's got a speed, he's got a shape. Right now he's a turtle. You can set his thickness. If you use, you know, the color thing with the multiple parameters like we were doing for a while when I had blue tacked on there, he's got two different things. He's got a flag in him that indicates whether he's supposed to fill or not, you know, and that's the begin fill and that's the end fill. So he's got a lot of information. What else is that turtle keeping track of that we're not keeping track of for him? It's really the most obvious stuff of all that I skipped while I was talking about this other stuff.
The graded positioning.
Yeah, his positioning. As far as turtles are concerned, the middle of the screen is 0, 0. And his heading is 0. Now this drives aviators and you know, I had a pilot and this just drove him crazy. But 0 degrees is that way. Better than that way in turtles. Don't know why they did that. But anyways, so he starts off at 0, 0, going 0 at degree 0. And you can change his direction, you can change his heading, and you can change his position. You can even make him teleport from one place to another with a set X and a set Y. Why not do that? Let's get him somewhere else on the screen and make him draw a circle. So above this main loop, whatever, I'm going to do Leo.setX, and I'm going to send him off to some corner of the screen, like 150. That changes his position. Leo.setY, also at 150. So you know, like the XY coordinate system, it's going to put him up there in the corner. And then let's make him draw a circle. Why not a, well, we've already used, why not a black circle? Leo.color, parentheses black. And there's a whole bunch of different colors you can use. I'll show you how to find them. And then Leo.circle, and when you issue the circle command, you specify the radius. I want this thing to have a radius of 50, so it's about the same shape, size as our other things. Because you know radius is just half the circle. Diameter is the full width of them. It's not going to be a full filled circle though, because I forgot my begin and end fill statements. All right, that's kind of lame. He actually left a line while he was moving. We could tell him to lift his pen and to lower his pen when he's doing that, so that we could draw shapes or whatever without lines connecting them all. Good enough as this demonstration goes. But we can demonstrate some other things about turtles. Like loops. I wonder if there's a way to erase the screen. Clear screen turtle. I should just show you how I Google information like this, because Google is your programming friend. Python turtle erase screen. Well, I'm not seeing the clear screen. I may skip that part if I can't figure it out. Clear. That'll work. Okay. We didn't use this window object that we created here when we did windows equal to turtle.screen, but we're going to do that now. And no, I'm going to speed my turtle up. I'm kind of tired of watching him go so slowly. I'm going to compromise him. I'm going to make him a 5. That's kind of fast, but not as fast as possible. Okay, so down here, window.clear, parentheses in parentheses. I'm just running it to make sure it works. Okay, cool. And also would like to remember, why is it doing that? Turtle, Python 3, set screen color. You'll find that when you Google questions, most of the answers are going to be on Stack Overflow, which is an amazing site. It didn't even really exist 10 years ago as far as I know, but it's like almost all the sum total knowledge of programming is here now. Okay, BG color. This might work. Gonna give it a shot. Win.bg color, I don't know, silver. Is that a real color? We'll find out. Yeah, alrighty. Where do you find these colors if you want a complete list of them? Go to Google and type TK space colors. Sounds strange, but you'll get a list of a vast panoply of colors. It's not scrolling it. Well, that's not a good one. This is actually a program for demonstrating all the colors, and I don't want to demonstrate them all. I just want to see them. Okay, so you can see there's a bunch of colors.
What'd you say to Google?
TK space colors. So I'm going to change silver to thistle, just for giggles. Okay, I kind of liked gray better. Back to silver. Okay, let's illustrate a loop. We haven't used a for loop yet, so I'm not digging the idea of doing a for loop now. I think I've shown you while loops already. So what we need is some kind of counter that indicates how many sides we've drawn. So I'm going to call it sides. Sides is equal to 0. And the first thing I want to draw is, let's draw a hexagon. We need the angle that he's going to go. Angle is equal to, just like I drew up here, this isn't a good representation, but 360 divided by 6. That's how many times he's going to turn. I'm regretting making this sides is equal to 0. I'm going to erase all of that, and I'm going to type it again. Just make yours match. Sides is equal to 6. Angle is equal to 360 divided by sides. Now I need a variable which indicates which side we're on. And if I make it side rather than sides, which is maybe how I would do it, it's going to be hard for y'all to type, so I think I'm just going to make it S. Right now we've drawn no sides. So while S is less than the number of sides, colon, let's go forward, excuse me, Leo dot, you can abbreviate forward to FD. Go forward 100. Then turn right, Leo dot right, our angle. And then we need to add 1 to S. S is equal to S plus 1. Then stop indenting. We're done. I'm going to even put a comment here. Whenever you stop indenting, that's the end of the loop. If I did this right, it should draw a hexagon. Or not. Do I need to reset his color and all that? I probably shouldn't have erased the screen. Usually I just have it start a new script. Leo.color red. I'm just trying this. While I'm poking around, you may not want to follow all these commands. Yeah, that did it. Okay, fine. After you change him to silver, pick a color for him as well. The window became silver, but Leo needs his own color again. Kind of weird. Now that we've written this as a loop, it's kind of modular. If we want to make it an octagon rather than a hexagon, we could change that to an 8 rather than a 6. And when he runs, we see him draw an 8-sided shape. I'm kind of wishing that was at the center of the screen. I could do another set X and set Y to get it back to the beginning before I cleared it. Not going to bother. I'm going to walk around and make sure everybody's going okay. The larger the number of angles, the more closely it looks like a circle. So I changed it to 360 sides. Well, that didn't work.
You have to decrease the distance down the way.
I need to decrease the distance. Yeah. Okay. Well, I should have made the distance its own variable. But instead of drawing 100, if I make the sides 360, it better be something like 1 pixel. So I'm changing this line to put in a 1. Here we go. He's so slow. That's because it's having to make a lot of updates. It's going forward 1 pixel, it's turning right, it's going forward, it's turning right. Notice that the circle command that it uses, though, was really optimized and went really fast. I'm not sure the difference, why they're able to get it to work that fast. Okay, what else does he show with turtles? The author. You can change the thickness of the line with dots pin size. And you can have more than one turtle drawing at the same time. That's kind of cool. That's using the stamp command. Every time you issue a stamp, it leaves a copy of the turtle behind. So he lifts the pin, he stamps, then he goes forward and he does something. We may as well play with that, but I feel like pushing him back in the middle of the screen. So again, Leo.setX 0, Leo.setY 0. But before we move him, I'm going to lift the pin. So Leo.pin. How come it sometimes pops up a list of functions and other times doesn't? How come sometimes it has underscores and other times it doesn't? Questions for greater minds than mine. Okay. Here's a simpler version of a loop. For x in range 30. We haven't used for loops, we haven't used 30s yet, but range statements, but that's okay. You'll remember them when we come back around to them later. This just counts from 0 to 29. Now what do we want him to do? We want him to leave a stamp, leo.stamp. Then we want him to go forward, leo.fd. I don't know, not very far. 5 pixels. And then we want him to turn left, but not very far. Maybe 5 degrees. Oh, I need to fix that circle. I'm going to change this back down from 360 to something reasonable, like 6. Sides, just because it's taking too long to draw. Alright, that wasn't terribly cool. What could we do to make that more interesting? We could make him go further before he leaves the stamp. We could increase his range. Let's try both of those. Let's make him go, I don't know, 15 rather than 5. So I'm going to change that leo.fd to leo.fd15. And I want him to draw 300 turtles. So I'm changing that to for x in range 300. How did he get the spiral effect? He didn't turn the same angle every time, or he didn't go forward the same distance every time. One of those two things changed in order to get him to spiral. So I'm going to go look at his code. Oh, he has a variable called size, and he adds onto it each time. We can do that. Why couldn't we just add X to our forward command, though? Yeah, I'm going to do that. Where he says leo.fd, forward, make that leo.fd 15 plus X. So that's the line that I changed. And that way he'll go a little bit further each time he draws. That should get our spiral effect. Well, he spiraled right off the screen. Maybe his angle should be a little bit larger than 5. I'm going to change it to 15. There we go. I'm liking that. The other thing that would be useful to demonstrate with turtles is the idea of putting these things in functions so that I could draw a spiral anytime I wanted to with a single call. Or else I could draw a hexagon with a single call. Try to think. Let's, I guess, go ahead and look at the rest of this chapter, see what else he's demonstrating. Write a program to draw a shape like this. Write a program to draw a clock like this. Well, these are complicated. How would we do that? What is that angle? I don't know what that angle is. That's not just 360 divided by 5 because that would just draw a pentagon.
Triangles.
Pardon me?
You do a hexagon within triangles on the outside of them.
Yeah. Well, 72 degrees is what this one's implying. Let's go ahead and start a new one. Call them Leo 2 or Leo 3. New file. We're going to have to put the same thing at the top of this one as we did on the other one, which means we have to put import turtle. I'm not going to mess with any screen commands. Leo is equal to turtle dot uppercase T turtle. Let's get them drawing pretty fast. Leo dot speed. At least 5 or 10 or something, not 1. Alrighty, now I want something that will lift his pen, go to a certain place on the screen, and put it back down. So I'm going to define a function called relocate. And this is considerably more advanced than what we have done so far, and I don't mind doing that because the next time you see it, it'll be more familiar. So define, I think relocate's too long, I'm just going to call it move. Define move, and we want it to accept an x coordinate and a y coordinate. We are defining a function. This code doesn't actually do anything until it's called. So in order to get him to move, we want to lift his pen, then we want to do that set x, set y, then we want to put his pen back down. So, tabbed over, because we have a colon, and every time we do a colon we have to start tabbing, Leo.pin_up, parentheses, Leo.setX to the x coordinate, so within the parentheses put an x, Leo.setX, x, Leo.setY, y. Let's put his pen back down. Leo.pin down. Now let's define another function. So define flower. In for the number of circles we're going to draw. So flower, parentheses, in, colon. We need to calculate the angle again. So angle is equal to 360 divided by n. And we're going to draw in circles. We could do that with a while loop. While not? While s is, no. S is equal to 0. No, let's call it C for circles, the number of circles we've drawn. C is equal to 0. While C is less than the number that we want to draw, while C is less than n, colon, Leo.circle, I don't know, let's make it a small flower, radius of 50. And then turn an angle, Leo.left angle. Then C is equal to C plus 1. Then stop tabbing. Alright, since these are in functions, they're going to do absolutely nothing. I need to do a save as so I can actually run this. I'm going to call him leoflowers.py. Whatever you call them is already okay. And it doesn't do anything. That's because we defined these functions, but we never called them. It's like we wrote an essay, but we never went and presented it. So let's move, I don't know, let's move like 200, 0. And then let's draw a flower. A flower with 8 petals. Then let's move to negative 200, comma 0. And draw another flower with 8 petals. I think I could have increased the speed even more. So what is the point of this? The point of this is that we have defined these modules called functions that we can invoke with a single line of code. You know, previously if I wanted to move the turtle, I would have needed these 4 commands. Lift your pin, set your X, set your Y, put your pin down. Now in my code, anytime I want them to move, I can just call move and specify his X and Y position. If I wanted to draw multiple flowers previously, I would have had to type all these lines in again. 1, 2, 3, 4, 5, 6 lines. Instead, we are getting to invoke it with a single call. Bless you. Alrighty, I think we're about done for today, actually.